A written chemical reaction is a condensed, shorthand way to give as much detail as possible about a chemical reaction.
What we're looking at is a chemical reaction. Now, we're going to break down the components of this chemical reaction piece by piece. Let's start out by looking at the element symbols. Now, N is an element symbol. Specifically, it refers to nitrogen. If we go to the periodic table, we can look at each one of the blocks till we find the upper right of the table where we'll see N for nitrogen. So, we can repeat this process and go through and say, what's H? Going to the table again, we could find hydrogen. Now, our element symbols tell us what elements are involved in the chemical reaction. If we look at the numeric subscripts that are next to our element symbols, these tell us about the element that they're directly next to. So this 2 tells me that I have 2 N's. This 2 tells me that I've got 2 H's in that position. So, if I go over to this 3 on the right-hand side of the reaction, it does not tell me about the N, but it only tells me about the H, because the phase subscripts, this is important to note, only tell you about what they're directly next to. So I would have 3 H's. But what about the N? There's no subscript written here, and when there's no subscript written, we can assume it's 1. So I've got 1 nitrogen in that position. So, we've got our element symbols, and we've got our numeric subscripts. So let's take a look at our other subscripts. In this case, we've got all G's in parentheses. So these come in 4 flavors. We could have G. That means we would have a gas. We could have AQ, which means aqueous. And aqueous means we've got a substance dissolved in water. We could have S. Take a guess at this one. If we have gas, then S is solid. And that leaves us our 4th phase subscript, L. And L stands for liquid. The difference between aqueous and liquid is subtle, but think about salt. If you dissolve salt in water, you would have an aqueous solution of salt water. If you raised salt to a very high temperature, you would melt the salt and you would have liquid or molten salt. So there is a difference in using aqueous versus liquid. So let's move on to the next component of our chemical reaction, the arrow. The arrow we can think of as an imaginary dividing line for the left and the right sides of the reaction. The right side of the reaction we'll call the products. The left side of the reaction we'll call the reactants. We can think of the reactants as the ingredients in a reaction that we use to make the reaction occur. Think of it as cooking ingredients. You would need cheese and bread to make a grilled cheese. On the right side are products. This is what we're producing or making. Now, there's one piece of this puzzle that we have not addressed yet. If you've spotted it already, it's these large numbers out front, the 3 and the 2, and the nitrogen doesn't have anything here, but again, because it doesn't have anything out front, it's just a 1. So these large values in front of our element symbols are called coefficients. Now these coefficients apply to everything in the chemical formula that's directly next to them. So the 1 that's out in front of nitrogen applies to the nitrogen, and the 2 out in front of the NH3 applies not just to the N, but to the H as well. And it applies not just in an additive fashion, but it multiplies. So let's take a special look at the 3 in front of the H2. This 3 applies to the H, but it's also going to interact with our subscript. The 2 said that we had 2 H's, but now we have a 3 to bring in also. These values multiply. 3 times 2 would give me a total of 6 H's. Let's repeat the same process for NH3. I have a 2 out front that applies to both the N and the H. I've got a 3 that only applies to the H. So whereas before we said we had 3 H's and 1 N, we now have to take our 2 into account by saying 2 times 3 H's for a total of 6 H's, or 2 times our 1N for a total of 2 N's. Now when we're completely done with this process of going through, we should have the same number of atoms on each side because a good chemical reaction will be balanced. So the only component we haven't tackled yet is our N2. We've got a 1 out front, we've got a 2 next to our N, so where before we had just 2 N's, we take our coefficient into account by saying 1 times 2, so we've got 2 N's. We said that our reaction arrow serves as an imaginary dividing line between reactants and products. On the left-hand side, based on my math, I've got a total of 2 N's and 6 H's from each of my calculations. On the right-hand side, I've got 6 H's still and 2 N's. In terms of cooking, it makes sense that you won't end up with more food cooked than the raw ingredients that you started with. So we need to balance things from left to right-hand sides. So just as a recap, large numbers in front of our element symbols, coefficients, and coefficients multiply through the entire formula. Phase subscripts, numeric subscripts, only apply to what they're directly next to. So numeric subscripts. Our reaction arrow provides us that imaginary dividing line between reactants and products, and also gives us directionality. So just as we read left to right, we also move through a chemical reaction left to right. So that's our arrow. We've got element symbols, our N and our H, that tell us what type of atoms and elements we're dealing with. And lastly, we've got our phase subscripts. And the phase subscripts tell us what phase that particular substance is in: liquid, solid, gas, or aqueous.